This is code.org. I'm currently working on their CS Principles course. I'm on Unit 3, Intro to Programming, Lesson 6, Functions and Top-Down Design, Part 2. Do this. You should already have worked with your partner to break down the design below into multiple layers of functions. Now that you have an opportunity to program your solution, here are a few things to keep in mind, right? So you should have gotten a paper. If you don't, if you go back one to the part one of this lesson, it has it that kind of lays out top-down design, and you have worked through with your partner how and written down on your paper some strategies for solving this. Identify useful patterns that can be reused and give them their own functions. Remember, the function you design can call one another. This is how to create layers of abstractions, right? Yeah, so we can have one function call another function that calls two functions. That will make more sense as we do this. Functions should be given names that are descriptive and meaningful. Your program should be kicked off with a single call to a function that makes calls to subsequent functions. Great. All right, so let's do this. Right off the bat, so our program needs to be started by a function. So, well, no, let's actually, I'm going to drop. Yeah, to start our program with a function, I'm going to do a function call first, which sounds weird because we don't have a function, but I know because I want to do a function right below it. I'm just going to call this function main. It is going to call all of my other functions. All right, so I know I have that now. Now, what do I want to do? If I want to create this shape right now, I know that I'm going to want to go up to the top and turn around. And so it's kind of up to us how many functions we would like to do this in, how many steps we would like to do this in. I'm going to start with that as a function. So let's call that forward. Oh, let me just check what they gave us. Oh, and we can, okay, so we need to turn right. We're definitely going to need that. All right, turn right. Okay, and to turn right, like we have been doing, we're going to need to drop in 3 turn lefts. Right? I like to debug a lot. I like to test a lot, so I'm already going to test this. Now, I call my main function, so my main function is the one that's going to run. Right now, turn right is never going to run unless I call it. So I'm going to call it in my main function. Let's see here. All right, so that one is working. Great. And not called, it's called right there. Yep, okay, so that one's working. Huh, weird that it does that, but okay. Now, we need to also have a function, again, to go forward 3. Let's have a turnaround function as well. So to go into a 180, what we would need to turn right, we could say turn left twice, or turn right twice. So I'm going to call this turn around. It would be more productive to use turn left twice, because that only runs one code, whereas this runs 3 lines of code to turn right. Let's double check this one now, turn around. I'm going to get rid of our call to turn right, because I just want to try my turn around function. I'm going to close. All right, and let's test this. Perfect. Okay, so now we have a function to turn around as well. Now, we need to, well, we're going to need to go forward. I think that's 3. And then turn around. Okay, so let's start there. We'll call that, I'm going to use another function, honestly. I'm going to say forward 3. And I capitalize that. And so then move forward once, twice, and 3 times. Okay, so let's go ahead and run that with our turnaround function. Wow, that was fast. pin down automatically? I guess so. All right. And then once we're like this, okay. Once we're like this, what do we need to do? Well, I think we need to go forward one and either turn left or turn right. So I'm going to drop this in. Ooh, I wonder if we can do this whole thing without ever turning right. Maybe not. All right. So we want to go forward and turn right. And we're going to, this is again an action we're going to be using multiple times. So it's going to be forward and then left. It's going to be in a function. Forward, left. Okay. And then, so this is actually going to be forward, left, and then forward again. And so, oops, I should put move forward in front of that. And then I need to move forward behind it. And then we do want to call this right here. So turn around, forward left. Let's see what this all does. Okay. So now what do we want to do? We want to turn around and go forward 2. And since we have to do this so many times, I'm going to, again, you know what? I don't need another function for this. I can say forward and then cross. So because I'm going to go forward, I'm going to turn left, then I'm going to turn around in here. And this is what they mean by abstraction. So I'm going to use turn around in here because I am calling this function inside of another function. And then I want to go forward twice. Okay, let's try this. Whoops. Oh yeah, because I got rid of forward left. I'm calling it forward cross because I'm going to go ahead and go across the T. Oh, forward cross. Whoops. There we are. That looks good so far. And then I want to call another function in here, which is forward, which is turn around. And so each time we do a function call, right, it looks for that in the program and runs the code inside. So right now my code is going to go move forward, turn left, move forward, turn around. What's that? Oh, there it is. Runs turn left, and then drops back and starts going through this code again. All right. So forward, forward. We need to turn around again. And move forward. We need to move forward, turn around, move forward. Oh, maybe like this. There we go. And this is where we would want to turn right and go down. Function call, turn right, and then forward twice. All right, and then we can either go left. Perfect. So actually, let's see, forward 3, call before this, turn around. Okay, so I'm gonna put turn around inside this, and I'm gonna put forward 3 inside that above turnaround, and I'm gonna call this draw cross, because that will create a whole cross on its own. I'm gonna drag this guy up here, and let's test. Yep. All right. Turn around. And then, okay, good. And then we are going to turn left going, I think. So let me try something. Two. We just double check. We got, yep. And so then I'm going to do turn left, drop a function, turn left, drop my function call. And then I probably want to turn left again to be facing how I was at the beginning. All right, I'm going to hit run. Let's see what this does. That, your program should kick off with a single call, which is right here, main, to subsequent. So if we were to only want this to make call to functions and not to have individual commands, I could put turn left down here. Let's go ahead and do that. And then all I'm doing is drawing cross. Boom. All right, I want to go through this because this is a bunch of code. So the code that worked for me. First off, this main here is calling a function. That is saying to the computer, hey, run something called main, run a function called main. And the computer says, okay, and starts looking for that. It finds it here, main. Oh, all right, I'm going to run this code. It has all these other functions. It does not run these functions. It does not run them. It's interesting though that says it's not used. It doesn't run them because they didn't even give us move forward, turn left, turn, yeah. It doesn't run them because they're defined. All of these functions don't get run yet. They're there, they're ready to be used, okay? And I do use them obviously, but they do not get used until I write their name somewhere. So, computer says, oh, I need to run main, starts running this code. Draw cross, okay, where's that? Oh, here's my code. And so then the computer will move forward 3. Wait a minute, what's that? Oh, here it is. Okay, move forward once, twice, 3 times. Got it. And the computer does that. Then, oh, I need to turn around. Okay, what's that? Turn right, turn around. Oh, turn around. Got it. Okay. And then it runs that code, right? We go left twice, goes back up here and says, okay, now what? Move forward. Okay, turn left. Okay, move forward. Okay, turn around. Oh, okay, I need to turn around again. Where's that code? Here. And it runs that. Move forward. And this is what they mean when they say abstraction, because we're running functions in other functions, right? We're calling functions in other functions. Move forward, turn around again, move forward, right, forward, left. Okay? And if I wanted to clean up this code, I could even have something that says, like, is there any redundancies here? So I have forward, turn around, forward, turn around, forward. So that could be a function too, right? Because what that's drawing is the cross part, right? The T part. So I could have that as a separate function as well if I wanted. Anyways, and then once it gets to turn left, we're back at the bottom. The turtle or the mouse pointer turns left, and it says, okay, done with this function. Ends up back up here and says, all right, I've drawn one cross. Now what? Oh, do this again. Finds the code and runs through all of it again. Okay. So this is the code that worked for me. Great. Let's keep going. Oh. Oh, okay. Interesting. I wonder what happens if we rename this. Oop, I'm going to hit Control Z real quick because I needed to know. What about now? Ah, it didn't like that I named it right because they actually named theirs turn right. Okay? So do not name it turn right. If you use a function like that, I just named mine right and it works fine. And then I called it here. All right, now let's keep going. Ta-da!